Oh.
Yes. Well, yeah, thank you for being here at our media workshop on surface water and ocean topography for SWOT satellite mission and data dashboards, useful tools for journalists to use in their reporting. This will be fully recorded and available on our YouTube channel for later viewing, and any useful links or materials or other information will be made available to journalists on our press information exchange. And with that, I'll turn it over to Jane.
Great. Well, thank you everyone for attending. We've got Angelica Rodriguez from NASA's Jet Propulsion Laboratory, who will be giving a brief intro. And then we have Merritt Harlan from the United States Geological Survey, who will be talking about the water information from space dashboard. And then we have Mike Durden from Ohio State, who will be talking about the SWOT biz dashboard. Yeah. If you want to.
Sure.
Take it away.
Thanks, Jane. I'm excited to give you all a very brief introduction before I hand it over to Merritt and Mike to do a deeper dive on the dashboards.
I'm clicking.
It is great. So the SWOT mission is a joint mission with NASA and the French Space Agency CNES, and also has contributions from the Canadian and UK space agencies. As the name suggests, SWOT measures the height or topography of all Earth's surface water, including lakes, rivers, reservoirs, and the ocean. With SWOT's novel technology, we are able to measure the height of water surfaces over greater distances and with better clarity than we ever have from space. Today, we'll be focusing on freshwater bodies specifically, and the data that SWOT's been collecting since April of 2023. SWOT observations are providing key information to understanding how Earth's freshwater is changing and how that will impact communities and environments. But SWOT data can be a little bit challenging to digest and analyze, so we're working to try and make it a bit easier to use. To do so, we've worked with USGS and the Consortium of Universities for Advancement of Hydrologic Science, or COASI, to build new tools that we're calling dashboards, which will allow easier access to SWOT data for a given area and allow users to visualize this over time within a web interface. The first of this is the Water Information from Space, or WISP dashboard. The WISP dashboard focuses on the United States and shows SWOT observations alongside observations taken from within a river by ground-based instrumentation deployed by the US Geological Survey. Through having these observations directly coincident, we are able to see how the water elevation is changing under various conditions. However, once we get outside of the US, this ground-based information is a lot harder to come by and is a limiting factor in being able to monitor a number of lakes and rivers over the global hydrologic system. So to address this, we are leveraging the SWOT satellite and the partnership with COASI to deliver SWOT information in the SWOT biz dashboard. Called SWOT biz, this dashboard allows users to search in an area of interest and view all of the SWOT observations for that location over time. This is really critical for places that would otherwise be unmonitored. So with that brief introduction, I'd like to pass it over to Merritt to give you a tour of the WISP dashboard.
Thank you. Yeah, thank you for being here. My name is Merritt Harlan. I'm a research hydrologist with the US Geological Survey. Actually, briefly, I just need to swap what's being shared here. Okay. Okay, great. And as Angelica mentioned, I'm going to be talking about water information from space, which is a new USGS dashboard that displays data from the surface water ocean topography satellite using a really cool tool that NASA developed called Hydrocron. And so this dashboard pulls in data from SWOT and displays it alongside our on-the-ground monitoring of rivers and lakes nationally through our gauge system. And you can, scroll around and pan and zoom to water bodies that might be of interest, or you can also use this filter tool. So here, if I type in the Potomac River and add this as a filter to my river layer on this menu of data options on the left, we zoom into the Potomac River. And if we can click on a section of the river that's co-located with a gauge here, for example, the Potomac near Shepherdstown, it will query SWOT data for that river. And it will also pull up USGS daily gauge information as well. And so on the left-hand axis here, we have SWOT water height, and this is expressed in elevation, typically above sea level. And so here, this river varies about 2 meters. And then on the right-hand axis, we have USGS daily gauge height. And you'll notice that these two y-axes are a bit different, and that's because our gauge height data is reported to an arbitrary datum. In this case, 0 would be, the bottom of the river up to 2 meters, which is the highest observed. And so again, in these black dots, we see the time series from SWOT, and then in green, we see time series from USGS. And these plots can be helpful in diagnosing the accuracy of SWOT, how well is SWOT tracking changes as the river goes up and down across different dates. We can also toggle on or off, for example, ice affected data. So we've automatically filtered out any data that potentially could have ice or snow covered. You can also hyperlink here to a real-time data from the gauge, as well as download the SWOT data into a CSV time series so that you could easily analyze it or pull it into another application, for example. And so in addition to enabling a comparison between SWOT and gauges on this dashboard, as Angelica mentioned, a really exciting aspect of SWOT is that we can now monitor all these water bodies where we don't have gauges as well. So for example, if I click on Liberty Lake, we can see a time series over time, perhaps a couple of anomalous measurements that might not be as accurate, but we can measure the change in water height at many different locations where we don't have gauges, which is really exciting. And some other quick aspects I'll just highlight is we do also have a tutorial that has more information, as well as an FAQ section and an about SWOT page up here. And again, I did want to have the caveat that here we're only showing data for the US, but SWOT is a global satellite. We just focused on it here to emphasize the comparison with our gauge site information. But next, Mike will talk about the more global facing platform SWOT is.
Thanks, Merritt. Just as Merritt said, SWOT is a global mission. And some of the science objectives for SWOT are to better understand the entire water cycle, how it works in different places, and how it's responding to stimuli. And so when you open SWOT Viz, similar to WISP, you can think of SWOT Viz as maybe just a lighter version with not as many features that allows easy data exploration. You get a map, and we'll first start by exploring what SWOT data look like on the Amazon River. The Amazon is far and away biggest river in the world by any metric. Here, this particular reach, which is highlighted when I click on one part of the river, is about 20 kilometers long. And actually, the river is about 5 kilometers wide in this place. So we get a little bit of additional metadata as well as some descriptions of each of these fields here on the left. And if we select plot, it will plot a time series. By default, it's just giving us data since September. So we'll go and ask for data going back to the beginning of this calendar year. And what you see is the Amazon's annual cycle of filling and emptying as a result of the large precipitation that we get seasonally in the tropical areas. And this flood wave actually is about 8 meters from top to bottom, or 24 feet, about the size of the 2-story house. So the Amazon is the biggest river in the world, but let's now go to France. So as Angelica mentioned, SWOT is a collaboration between US, France, and the UK and Canada. So we're gonna go to city of Bordeaux. So there's a little search bar on the left there, and you can zoom straight over. And this is the Bordeaux wine growing area, right, in the city of Bordeaux. And this particular reach is actually just upstream of the Bordeaux or the Garonne tidal estuaries. This is on the Garonne River. So when we, and you can actually see that here, the average water elevation is about 0, right about sea level. When we ask for a plot, you see a little bit of a messy up and down. We can explain some of that in 2 different ways. First, you may notice the data quality flagged over to the right. And right now, SWOT Viz does show 3 different kinds by default of SWOT data: good, suspect, degraded, and bad. So most users, most of the time, should be looking at the good and suspect data. And I think this is actually an important point for today. SWOT is a first of its kind mission. There's not something else out there like this. And we are still learning a lot about the phenomenology, like how the radar actually interacts with the trees and the land and the mud near the rivers, and learning how to most accurately get the water elevations. So it's important to consider data quality. What you can see once you have this plot is a sinusoidal pattern. Of course, we're real near the coast, and this is tidally forced. Of course, the tides go up and down each day, but because SWOT's orbital cycle hits the different tidal cycle at different times, you still see the resolution of the tides. This also helps see some of the other SWOT data products. Here, we're still looking at water surface elevation, just as Merritt did before. But we also have a measurement of slope along this reach. This is about a 10-kilometer reach, and this is the drop in water height divided by that 10 kilometers. At first glance, this may seem a bit of a strange plot, but there's something interesting here. So the most slopes in these tidal areas are around 0. So you might expect it's very flat here. But if we select a couple of data points, and actually I'm first going to change this to just run through March. If we select a couple of data points, we can now go down here and view what's called a longitudinal profile. A reach is 10 kilometers long, as I mentioned. And that data point for that 10 kilometers is computed from what we call nodes, so 200-meter locations down the river. And so when we look at the long profile, we're able to see what that water elevation looks like going from downstream to upstream. So looking at this top plot, this is what most rivers look like. It's steep, the elevation is higher at the top of the reach than the bottom. Further from the ocean is higher, right? And so you have this slope going downhill, water flows downhill. But there's also times during the tidal cycle when the elevation in the tidal estuary comes up and flow goes backwards down the Garonne. And these dynamics are really important to study and to suss out in different parts of the world, especially with concerns about sea level rise. We're going to go to one more place, going from the Mediterranean climate of France to Alaska. And while Alaska actually is also included in WISP, I wanted to take just a brief moment and talk about the Copper River in Alaska. And so USGS, as Merritt mentioned, is tasked with measuring river stream flow, the amount of water moving through rivers into the world's oceans. This is super important for water management and for understanding hydrologic processes. And in places like Alaska, it is very, very challenging to get the kinds of measurements you need to maintain these gauges. So what we're doing is we're working with the USGS Alaska Science Center on the Copper River and a couple other sites where they are going out at the time of SWOT overpasses. Oops, and are measuring what the river stream flow looks like on that day, on the exact time that SWOT is flying over. And by comparing the measurements from the USGS in situ and the SWOT data, SWOT discharge algorithms are turning those into river discharge that will then be accurate in this place. SWOT will produce discharge everywhere, but it will be accurate, most accurate in places where folks are providing these data to help constrain it. And so our hope is that in places like Alaska and everywhere, there'll be better sense of global river discharge and a better monitoring of these precious water resources.
Okay.
Yes.
Okay. Right, and so with that, is that all the introductory material we have? Yeah. Okay, great. So I think that will transition over to the other portion, and I will stop the recording. As I said, this will be posted on YouTube, and we can share it with useful links for folks, link to some of those FAQs and tutorials also that you mentioned, so people can really dive in. Yeah.